one of the present generally noticeable and high-level physicists, has communicated his assessment with regards to this issue. Kaku, perceived for his remarkable commitments to the fields of material science, has as of late affirmed that the James Webb Space Telescope has found 6 monstrous cosmic systems that researchers thought couldn't exist. These examinations can potentially open up new aspects in our logical comprehension of the universe. It is, in this way, astonishing and worth keeping an eye on these advancements. Kaku is an exceptional figure in the logical field, a physicist of American and Japanese legacy. He is thought of as a master in both traditional exploratory material science and quantum mechanics. Unlike some more moderate and wary researchers, Kaku doesn't have a place with that bunch and has been open to the astonishing aftereffects of the James Webb Space Telescope mission. We are truly glad that this distinguished researcher has chosen to end his quiet and publicly share what can never again be denied. The energy and, practically, most entertained tone of the prestigious heavenly physicist is obvious in his remarks on the revelation made by the James Webb Space Telescope, expressing that this has been the feature that has aroused his curiosity. Join us to discover the ramifications of Michio Kaku's disclosure of these 6 monstrous cosmic systems. Kaku is a researcher who has always been willing to consider new hypotheses. Throughout his life, he knows that Einstein's conditions of relativity and Newton's regulations are inadequate to capture the full intricacy of the universe. Kaku comprehends that the disclosures of the new telescope have the possibility to enhance the logical field. Although many of his colleagues have not had the option to embrace this view, it is creating concern and insomnia among defenders and adversaries of quantum mechanics. However, this just incites chuckling from Kaku. The JWST has uncovered the discovery of 6 monstrous galaxies tracing all the way back to the earliest seasons of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed just 200 to 700 million years after the Big Bang. The group of astronomers who made the discovery have named these outstanding systems universe breakers, because their affirmation would alter our entire comprehension of the universe. Something doesn't fit here any longer. The theory of how things came to be tells us that the universe was a hopeless train wreck after the initial event. The primary solid objects took many millennia to form, and it took countless additional years for the objects to reach adequate thickness and produce light. The development of complex structures like galaxies was believed to happen much later. Some of the newfound galaxies exceed the Milky Way in size, and their massive glow shows that they were likely forming many new stars each year, whereas our galaxy forms stars only occasionally. It remains uncertain exactly when the first galaxies formed. Scientists have not had the option to determine this up to this point. The main thing that is clear is that initially, there may have only been single stars or groups of stars which eventually joined together to form increasingly large accretions until dwarf galaxies developed. The little galaxies experienced different systems and progressively grew. According to past speculations, highly coordinated and gigantic galaxies could not have existed at that time, raising whether or not the universe is much more established than previously accepted, or whether complex toroidal cosmic plans grew significantly sooner. This situation is challenging to make sense of for moderate science, which actually finds issues with this model. Some parts of physical science have intensely rejected to acknowledge this revelation and question potential mistakes in the age estimations. Kaku knew about this and had this to say: "There are numerous instances of old and bogus speculations that tenaciously persevere due to the esteem of some researchers. Many of these speculations were possibly undermined when a significant trial uncovered their deception. In this way, the crucial work in any science, particularly in physical science, rests inside the experimentalists who keep the scholars legitimate. Truth be told, on Earth, we have close to zero insight into the valid origins of the universe. The Big Bang hypothesis was laid out in 1927 based on perceptions of the development of the universe. These data prompted the conclusion that the universe started from a solitary point and has been extending from that point forward. At the time, it was hard for individuals and researchers to imagine a universe with a beginning and an end. The possibility of a universe that had consistently existed and was limitless in time and space was past individuals' creative imagination. Even today, researchers still face hardships in getting it. However, it is critical to consider these probabilities. These new exhibitions don't fit at all with what scientists have based for a really long time on the Big Bang theory. Anyway, science has shown endlessly time again that reassessment and receptiveness to novel thoughts are an essential piece of the logical process, just like the affirmation of certain speculations and perceptions. When Einstein was a kid, it was accepted that the stars and planets were immovably fixed in the universe and these specific designs involved a characterized space. Anyway, we currently know that all that in the universe is moving. Planets circle, stars move inside their systems at many kilometers each second, and whole systems move quickly through the universe, the destiny of which we can't yet try and foresee. Today, researchers are challenged to acknowledge awkward insights and figure out that speculations are not just theories and not outright insights until they are thoroughly tried or affirmed by precise perceptions. The possibility of the Big Bang emerged from the acknowledgement that cosmic systems are getting away from one another, and this distance is relative to the distance from Earth. This perception, known as Hubble's regulation, proposed that the universe was growing. For quite a while, components like enormous foundation radiation and the red shift of light from far-off systems and other cosmological designs appeared to support this hypothesis. Anyway, it is essential to recall that in the past, individuals who believed that the Earth was flat and that the Sun rotated around us likewise had this sort of proof for their suspicions until happenstance or innovative upgrades came along that provided a more clear and more precise picture. Right now, we are seeing a comparable situation. Researchers expected the new JWST to affirm the suspicions related to the Big Bang. However, rather they have come across these 6 worlds that appeared to be incomprehensible. This advises us that science is continually advancing and that researchers must be open to new revelations and re-examine existing speculations based on the available proof. Scientists use redshift as a device to determine specific amounts in the investigation of the universe. Redshift, also known as the Doppler effect, alludes to the change in the shade of light as the light source and the observer move relative to each other. To comprehend this, you can envision stopping and seeing a vehicle coming towards you. As the vehicle moves towards you, you hear the engine getting louder. Anyway, once the vehicle passes you or gets away from you, the engine changes. This is because the sound of the engine varies as the vehicle moves. The same is valid for light. When a light source, for example a far-off star, moves towards us, the light we see shifts towards bluer tones. Then again, when the light source gets away from us, the light moves towards redder tones. This peculiarity is called redshift. Physicists have converted redshift values into speeds and distances for estimation in the investigation of the universe. Anyway, noting that is significant, little mistakes in these estimations could have massive impacts. The estimation techniques recently utilized are presently under audit, and it is intriguing to see what results researchers will arrive at with respect to the most recent shows connected with our universe. It is important to consider whether they are truly based on redshift blunders or whether some researchers are simply denying current realities. This is an inquiry that requires thorough examination and cautious review of the information and techniques utilized in the research. As logical request advances, the disclosures achieved by instruments like the James Webb Space Telescope frequently challenge our assumptions about the universe. The new disclosure of 6 monstrous galaxies tracing all the way back to the early stages of the universe is one such model. These galaxies, which oppose ordinary speculations of cosmic development, raise significant inquiries concerning the course of events and systems associated with the advancement of cosmic structures. The James Webb Space Telescope, replacement to the Hubble Space Telescope, is outfitted with cutting-edge advancements that enable it to peer more profound into space and see with uncommon clarity. Its capacity to distinguish light from the far-off scopes of the universe furnishes astronomers with a window into the past, permitting them to concentrate on worlds that formed billions of years back. The disclosure of these old and enormous galaxies challenges existing models, which predict that such large designs ought to have formed much later in the universe's history. The ramifications of these discoveries extend beyond astronomy and into the domain of basic material science. They force researchers to re-examine established theories about the early universe, including the Big Bang theory, which posits that the universe began from a particular point and has been expanding from that point forward. While observational proof, for example, the astronomical microwave background radiation and the redshift of far-off galaxies initially supported this hypothesis, the discovery of galaxies that appear too full-grown for their age confounds this story. Michio Kaku, a prominent physicist known for his work in theoretical physics and popular science, has commented on these developments. Kaku, known for his ability to bridge complex logical ideas with accessible explanations, recognizes the extraordinary potential of the JWST discoveries. Unlike some of his more suspicious peers, Kaku embraces the idea that novel perceptions should prompt modifications in logical thinking. He has stressed the significance of exploratory proof in shaping our understanding of the universe, highlighting that speculations must constantly evolve to accommodate new information. The discussion started by these revelations mirrors the dynamic nature of logical inquiry. On one hand, there are defenders who argue that the discovery of early massive galaxies suggests a longer course of events for cosmic development than previously thought. This perspective challenges the traditional understanding that galaxies evolved gradually over billions of years through consolidations and accretion of